Hey guys, happy Tuesday. The sun is finally coming out. Yay. So let's get to our calculations. All right, so our first problem is 90 plus 1 and 61 hundredths. So we're going to rewrite that, right? And remember, when we add or subtract decimals, we need to line up our decimals. Okay, and the other thing that we didn't do in this case, remember I told you where yesterday we were talking about once we rewrote the problem, but we can easily do it here as well. We need to just make an estimate, right? So here I have 90 and 1 and 61 hundredths is going to kind of round up closer to 2. So my estimate is going to be about 92. Okay, so I know that this should be very close to that. Okay, so when I line them up, I'm going to do that and I'm going to bring this down. Then I'm always going to just start on the right. 0 plus 1 is 1. 0 plus 6 is 6. 0 plus 1 is 1. And my 9. So, and there's my answer, 91 and 61 hundredths. And we know that's really close to 92. So my answer does make sense. All right, let's talk about our number line. So our number line, same as what we talked about yesterday, just a quick reminder. So on my number line, if you notice, I kind of went back and I did these in orange so you can see I'm taking my space between 0 and 1, and I would do this anywhere on a number line, and I look at how many spaces. So I'm always going to start here, and it's like my hop, right? I'm not counting this one, so I'm going to draw lines above. So here's 1 hop, 2 hops, 3 hops, 4 hops. So that tells you that this one, from what I drew my lines, is split into 4 equal pieces. So this one here, this first hop, actually, let me write it above it. This is like 1/4. When I do each of these hops is 1/4, right? Each hop is 1/4. And I'm saying that because of the fact that I split between 0 and 1, that space, into 4 equal pieces. Okay, what if you notice, because this one's talking about decimals, I labeled them as the decimal too. Remember, those are my benchmark fractions, benchmark decimals. So this one's 1/4, which is the same as 0.25, 1/2 or 2/4, right? Because I have 2 in there is 1/2 or 0.5. This is 3/4, this is 0.75, and this right here would be 4/4 or 1 whole. Right? So I'm looking here for 0.7. Well, let's think, and this is 7/10. 7/10 right away is larger than 5/10. So I know right away this anything over here would not make sense. So now I have to take a look. When I use my benchmark, I take a look and I can see this is like where my 75 hundredths is, right? And this, if I was turning this into hundredths, let me write that over there, that would look like this. So that's a 0. So 75 hundredths is going to be larger than 70 hundredths. So I know right away anything on this side of it does not make sense. So my answer has to be where it's going to be closer to like my B. Now, here's the difference. If I'm looking, so B is going to make more sense on my answer. If you picked C, I could see why you might say that. And this would depend on the testing part, just to say, because who's to say that that's in there? So they may call C right. But if you notice, if you pick D or A, neither of those make sense because A is a lot closer to the 50 hundredths or 5/10. And D is larger than 1. So this is going to be like 1 point something. Okay, so that wouldn't make sense. So B is probably going to be more of your answer, or like I said, if you pick C. This one's kind of a tricky one because they're both pretty close if they're looking at it. Okay, so we're into our fractions, right? Whenever we're adding or subtracting fractions, we need to have a common denominator, right? Because we're talking about size of the pieces. So in this case, and I'm going to keep it as an improper fraction right now when I'm doing my work, because it's a lot easier for me to keep them this way, and it just means maybe a larger value for my multiplication idea than it does for me to have to be turning it or regrouping when I have my whole. Okay, so when I'm looking this, I have 4 and I have 5 here. My least common multiple, which is what I'm going for, is going to be 20. So in order to get to 20, I'm going to multiply my 4 times 5, which means I have to do the same thing to the top. Let me see if I can get clear. And then I'm going to do the same thing over here to the 5. I'm going to multiply that by 4, so I'm going to multiply the top by 4. So I created my problems over here, and I was starting, this is my 20, right? Because I want my denominators to be the same. Now I need my numerators. So I'm over here, and I started to do the problem, and I thought, well, let me go through it together. 5 times 9 is 45. So I'm going to put my 5. I carry my 4. 5 times 1 is 5 plus 4 is 9. So I'm going to put that over here. 19 fourths becomes 95 twentieths. And over here for my 17th times 4, because that's what I'm doing. Remember, when I multiply fractions, I multiply across the top. I'm going to do 4 times 7 is 28. Carry my 2. 4 times 1 is 4 plus 2 is 6. So I have 68. So in this case, then I'm going to take my denominator stays the same because now it's 20th, so same size pieces. And then I'm just subtracting my numerators. So I just rewrote over here, so I have 20th. Now, when I look at this, I see I have 95 and here I have 68. This is almost 100 and this is almost 70. So my answer should be close to 30. If I'm really far away from that, I need to check my work. Okay, so when I'm taking a look, if I have 5, I cannot take 8 away. I'd have a negative number, so I need to regroup. So this becomes 8, this becomes 15. 15 minus 8 is 7, and 8 minus 6 is 2. So I end up with 27 over 20 as my improper. Okay, but it tells me here, answer as a mixed number. So as a mixed number, what this is doing is like 27 divided by 20. Or I'm looking at if I have 27 pieces, how many groups of 20 can I make? And I know from that, I'm going to make one group of 20. And on this one, I'm kind of not showing you the division because I'm just looking here. There's a 2 in the 10s. There's a 2 in the 10s here. So I'm making one full group. And then when I do 27 minus 20, because that's what it takes, I have 7 pieces left out of the 20 I need for the whole. And I know this is in lowest terms because 7 is a prime number. So 1 and 7 are its factors. And I cannot do 7 times anything to equal 20. Okay, so ironically, the next one is the same number as yesterday. Did you notice that? But the difference is, and let's take a look. So again, we can pick any of these spaces. And remember, we're going to look. I'm going to use from -2 to 1 to -1. I'm looking. I went 1, 2, 3, 4, 5, 6 places. Notice how I did that because that's telling me how many spaces it's between. Okay, so there's 6 spaces. So each line is worth some 6. If I go this way, remember we talked about as we go to the left, we start going down. So if I was using, because I knew it was 6, I'm going to mark this spot here. This is my -1. This space here, I'm just drawing an arrow so you can see it better, is going to be my -1 because I have that still here. I still owe my $1. But now I owe 1/6 more. So when I move, that's a bad one. When I move each time I move this way, I'm adding 1/6 more that I owe. So when I look here, I'm looking at my -2. So I know I'm going to start at least here. And then I have 4/6. So I need to move this way. So I got a shadow based on my light. I'm going to have 1. This is -2 and 1/6. 2, 3, 4. So my spot is going to be right here. It's going to be my -2 and 4/6. Notice, even though it seems like it's kind of weird because we're going farther in the negatives, when I get to the -3, that's like -2 and then 6/6 because it's a full. So I'm closer to my -3 when I have that point. Okay, let me